Welcome to Engineers Mindset. Now in this video, I'm going to show you everything you need to know about chain rule differentiation. I will also show you how when you see a problem, whether you're going to apply the chain rule or whether or not you're going to apply the chain rule. Okay, let's say I have y to be a function of u, and then I have u itself to be a function of x. Okay, so if this holds, it means now I can differentiate y with respect to u, since y is a function of u. So I can simply find the y, the u. Okay, also since u is a function of x, it means I can also find the u, the x. So if I can find the y du and I can find the u dx, and let's say the question says I should simply find the y dx. Now I'm simply going to multiply the two of them. Notice that if I multiply the y du to the u dx, from here the u can cancel what? The u. I'm simply left with what? The y dx. Now this is the chain rule, but how do we come about this? Now let's say I have y to simply be equal to sine 2x. Now y depends on the value of x. So let me now say let u be equal to 2x. If I say u should be equal to 2x, it now actually means that y itself is now equal to what? Sine u. Because in place of 2x, I'm calling it what? U. So if you closely look at this equation, you're going to find out that u is now what? A function of simply what? X. U now depends on the value of x. And then y itself depends now on the value of simply what? U. Y here depends on u. So such a function is what we call function of a function. If we have function of a function in mathematics, it means we must always apply chain rule to always what? Differentiate it. Okay, because here normally y was supposed to be a function of x, but I now transpose the equation. I said let u be simply 2x. That means y is now what? Sine u. So this now means that y is a function of u. Meanwhile u is a function of what? Meanwhile u is a function of x. So I have now a function of another function. So this is now y function of x. This is now y a function of u, and then u a function of x. It is called function of function. If that is the case now, then I'm going to employ the chain rule. Why? Simply because since y is a function of u, it only means that I can differentiate. It means now that I can differentiate y with respect to u. Since y is a function of u, it means that I can only differentiate y with respect to u, and that is simply dy du. And since y is equal to sine u here, dy du simply gives us what? Simply cos u. So I have this. Also, since u is equal to 2x and u now is a function of x, it means now that I can only differentiate u with respect to x. So I'll simply have that du dx, of course, if I differentiate 2x, I will simply have what? 2. So I simply have this. Now, if I know these two variables now and I'm asked to find the y dx, all I need to do is simply what? Multiply the two what? Derivatives. That simply gives me the y dx. Okay, so if I do that, I'll have that dy dx is now equal to dy, the product of the two derivatives, du times du dx. So notice now that du strikes du, I'm left with dy dx. This is called the chain rule of derivative. So whenever you encounter function of a function in any given expression while differentiating, you can only apply chain rule. And how do you know that a given expression is actually a function of a function? It is simply by what we've done here. So if you're able to establish these two facts, it means you can now apply the chain rule. And of course, we obtain the y du to be cos u, we obtain the u dx to simply be 2. So that means this derivative is simply dy the x is now equal to the y du gave us cos u multiplies by du the x simply gave us 2. So this is actually 2 cos u. Okay, but remember that we said let u be simply what? 2x. So in place of that u, we'll bring back the original value as what? 2x. So that simply implies that the y the x is actually what? 2 cos 2x. And that's how you go about that. All right, guys, I hope you find that video interesting and helpful. Please, if you do, I would like to get your thoughts in the comment section. And of course, if you're new to this channel, don't fail to subscribe to get more and more updates on videos and contents like this. I will see you in the next video. Thanks and cheers.